All right, so today we are going deep on the Ethereum white paper.
Yeah?
This is the document that,
Really kick things off.
yeah, it kicked things off for a lot of the dApps that we see today.
Yeah, a lot of innovation came from this document.
Exactly, and we're gonna try to break it down and see what makes Ethereum so different from, its predecessor, Bitcoin.
Absolutely.
And don't worry, we're gonna keep it jargon-free, so you don't have to be like a crypto whiz to follow along.
Totally.
But before we get to all that mind-bending stuff,
Right.
we do need to lay some groundwork with, Bitcoin and blockchain technology, right?
You got it.
It's like the alphabet before you write a novel.
Exactly. Can't understand Ethereum without understanding Bitcoin.
Yeah.
Think of Bitcoin as like a digital ledger,
Okay.
like a giant spreadsheet tracking who owns what.
Right.
And every time someone sends Bitcoin, it's like adding a new line to that massive spreadsheet
Okay.
showing where the coins went.
I see.
So let's say Alice sends 11.7 Bitcoin to Bob.
Okay.
That transaction gets recorded on the blockchain for everyone to see.
Okay, so that's great. But
Yeah.
how do we know this ledger is accurate?
Right.
Like, what's stopping someone from messing with it?
Yeah, that's a great question.
Or like, double spending the same Bitcoin?
Right. Well, that's where mining comes in.
Okay.
This is where it gets really clever.
Okay.
So imagine a whole bunch of powerful computers
Yeah.
all competing to solve a complex puzzle.
All right.
The first one to crack the code
Yeah.
gets to add the new block of transactions
Got it.
to the blockchain.
Okay.
So it's like earning the right to write the next page
Okay.
of Bitcoin's history.
So it's kind of like a race to
Exactly.
be the record keeper.
Yeah.
But that sounds like it would take a ton of energy.
Yes.
Is there a downside to all this mining?
Yeah, you're right. That's a big concern.
Okay.
The sheer amount of computational power needed. For this, it's called a proof of work system.
Okay.
It consumes a lot of energy. And that's actually a big reason why Ethereum
Okay.
is moving towards a different model called proof of stake.
Okay.
But that's a whole other topic
Yeah, we can save that for later.
for another time.
Okay.
But for now, just know that this mining process is what makes it virtually impossible
Okay.
for someone to tamper with the blockchain.
Gotcha.
It would take an insane amount of computer power
Right.
to rewrite history, and it's just not worth it
Yeah.
for most people.
Okay, that makes sense.
Yeah.
So we have this super secure ledger,
Right.
but what about efficiency?
Huh?
Isn't it like a pain to have to download this giant blockchain
It would be.
every time you want to make a transaction?
That's where those Merkle trees come in.
Okay.
It's kind of like a table of contents for each block.
Oh, okay.
So instead of downloading the whole blockchain,
Okay.
you can use this tree to quickly verify if a specific transaction is included.
Okay.
Think of it like being able to check
Right.
if a particular sentence is in a book
Okay.
without having to read the whole thing.
Right. So it's all about efficiency.
It's a key part of making blockchain technology
Okay.
more scalable.
Got it. So I'm hearing you right. It seems like Bitcoin is really just about
Oh.
tracking who owns what, right?
Well, that was the original idea.
Okay.
But people quickly realized
Yeah.
this blockchain tech could be used for a lot more
Mm-hmm.
than just currency.
Okay.
There were some early attempts
Right.
to build on Bitcoin.
Yeah.
Things like Namecoin
Okay.
for decentralized domain names,
Okay.
or colored coins
Uh-huh.
to represent other assets.
I see.
But these projects struggled
Yeah.
because Bitcoin's programming language
Right.
was pretty limited.
Okay.
Think of it like trying to build a skyscraper with just Lego blocks. You can only do so much.
Right.
Then Ethereum comes along.
Yeah. Ethereum's like, hold my beer.
Exactly. Ethereum was designed from the ground up
Right.
to be a platform for building a wide range of applications.
Okay.
One of the key differences is that Ethereum uses a programming language.
Okay.
It's called Turing complete.
Okay.
I know that sounds technical,
Yeah.
but it basically means it can do any computation that a theoretical computer can do.
Wow.
So it's like having a universal set of tools you
Right.
can use to build anything you can imagine,
Yeah.
not just simple structures.
Okay, so I'm starting to see
Sure.
how Ethereum took this blockchain concept and
Heck yeah.
blew the doors wide open.
Absolutely.
But we're only scratching the surface here.
This is just the tip of the iceberg.
Yeah.
We haven't even talked about the core building blocks of Ethereum yet.
Right, like those accounts and transactions and gas and all that.
Exactly.
All that good stuff.
All that good stuff.
And those smart contracts that everyone keeps talking about.
Yeah, that's where things get really interesting.
That's where things get really interesting.
Yeah, we have a lot more to cover.
We do, so we'll have to pick this up next time.
Sounds good.
All right.
Looking forward to it.
All right, great.
Yeah.
So last time we talked about how Ethereum took this whole idea of the blockchain and made it into a platform for like all sorts of applications.
Right. It went way beyond just cryptocurrency.
Yeah, but how does it actually work? Like, what are the nuts and bolts?
Well, it all starts with accounts.
Okay.
In Ethereum, everything revolves around these accounts.
Okay, so is that like my username on a website or something?
It's similar, but it's more like having your own mini program on the blockchain.
Oh, okay.
You see, there are two main types of accounts in Ethereum.
Okay.
There are externally owned accounts, which are controlled by, real people like you and me.
Right.
These are the accounts we use to send and receive Ether, which is like the fuel of the Ethereum network.
Got it.
And we control these accounts with our private keys, which are like super secret passwords.
Okay, that makes sense, but you said there was another type of account.
Yes, contract account.
Contract accounts, right?
These are where the real magic happens.
Okay.
Think of a vending machine.
Right.
You put in some money, press a button, and out pops your snack.
Okay.
A contract account is like a vending machine on the blockchain.
I see.
It's a piece of code that automatically executes actions based on pre-programmed rules.
So it's like a little robot that lives on the blockchain and just does stuff.
Pretty much.
Based on certain conditions.
Exactly.
Okay, that's pretty cool.
Yeah.
But how do these contract accounts, like, actually get created?
Right.
Do they just, like, appear out of thin air?
Not exactly.
Okay.
They're created by regular people, developers, who write the code for these contracts.
Got it.
Once the code is written, it gets deployed to the blockchain, and voila, you have a smart contract.
Okay, so smart contracts are just a fancy name for these contract accounts.
That's right.
Okay, I'm starting to connect the dots here.
Good.
But I still don't really get how this all works in practice.
Sure.
Can you give me a real-world example?
Let's say you want to sell something online.
Okay.
But you don't want to have to trust a middleman like eBay or Amazon to handle the payment.
Yeah.
You could create a smart contract that acts as an escrow agent.
Okay.
The buyer sends their payment to the contract, and the contract holds on to it until you, the seller, provide proof that you've shipped the item.
Okay.
Once you provide proof, the contract automatically releases the payment to you.
So the smart contract is like an impartial judge that makes sure everyone plays by the rules.
That's right.
No more worrying about getting scammed.
Exactly, and that's just one simple example.
Wow.
Smart contracts can be used for all sorts of things.
Okay.
Like creating decentralized marketplaces, managing supply chains, or even running entire organizations without any central authority.
Okay, my mind is officially blown, but if these smart contracts are basically just code, couldn't someone just write malicious code that does bad things?
That's a valid concern.
Okay.
And it's something that the Ethereum developers have thought a lot about. That's why the Ethereum network has this system called gas.
The gas?
Yes, gas.
Like what I put in my car.
Well, not exactly.
Okay.
Think of it as a fee you pay for each step a smart contract takes.
Oh, okay.
Every computation, every bit of data is stored. It all costs gas.
Got it.
And this gas is paid for in Ether,
the
native currency of Ethereum.
Okay.
This system has two main purposes.
Okay.
First, it prevents people from overloading the network.
Okay.
With overly complex or inefficient code.
Right, so it's like making sure nobody hogs the road.
Exactly.
By driving a gas guzzler.
That's a great analogy.
During rush hour.
Yeah.
Okay.
And second, it helps to prevent malicious code from running rampant.
Okay.
If someone tries to write a contract that does something harmful, they'll have to pay a lot of gas to keep it running.
Right.
Which makes it much less appealing.
So gas is like a security measure built into the system itself.
Exactly.
That's pretty clever.
Yeah, it's a really elegant solution.
Okay, so we've got these accounts, smart contracts, gas. But what about those transactions we talked about earlier?
Right.
How do those fit into all this?
Transactions are the lifeblood of the Ethereum network.
Okay.
They're how information and value move around.
Right.
When you send Ether to someone, when you interact with a smart contract, when you create a new contract, it's all done through transactions.
So a transaction is like a message that gets sent across the network.
Exactly. And each transaction contains important information.
Okay.
Like the sender, the recipient, the amount of Ether being sent, and any data that needs to be included.
Okay.
Remember those vending machine contracts? Well, the data in a transaction could be something like which button you pressed on the vending machine.
Oh, okay.
Which would tell the contract which item to dispense.
Okay, I'm starting to get the big picture here, but I have to admit, this whole Ethereum thing is starting to sound a bit complicated.
Yeah, it can be a lot to take in.
Are there any, like, downsides or potential problems with this technology?
Of course, no technology is perfect.
Right.
And Ethereum has its fair share of challenges.
Okay.
One of the biggest is scalability.
Okay.
As more and more people use the network
Right.
and more dApps are built,
Uh-huh.
things could slow down.
Okay.
Kind of like how a highway gets congested during rush hour.
So it's like a traffic jam on the blockchain.
You could say that.
That doesn't sound good.
It's definitely a concern.
What are the, developers doing about that?
Well, there are a lot of smart people working on solutions.
Okay.
And the Ethereum white paper itself outlines some potential approaches.
Okay.
One idea is to use something called sharding,
Sharding?
which is basically like
okay.
splitting the network into smaller, more manageable pieces.
Okay, so it's like adding more lanes to the highway.
Exactly.
Okay.
Another idea is to use something called layer 2 solutions,
Okay.
which are like side roads that take some of the traffic off the main highway.
Right. So it's like finding ways to route the traffic more efficiently.
Precisely.
Okay. So it sounds like scalability is an ongoing challenge.
Yeah, it's definitely something that the Ethereum community is actively working on.
But there are some promising solutions in the works.
Absolutely.
Okay. What about other potential problems?
Well, another concern is security.
Okay.
Since smart contracts are basically just code,
Right.
there's always the risk of bugs or vulnerabilities
Yeah, that makes sense.
that could be exploited by hackers.
Okay.
And once a contract is deployed to the blockchain,
Uh-huh.
it's very difficult to change.
Right.
So any bugs could have serious consequences.
So it's like launching a rocket into space. You better make sure everything is working perfectly
Exactly.
before you hit the launch button.
That's a great way to put it.
Okay.
That's why it's so important to have experienced developers
Right.
who know what they're doing
Yeah.
when creating smart contracts.
Got it.
And there are tools and techniques being developed
Okay.
to help audit and verify contracts before they're deployed.
So it's like giving the rocket a thorough safety inspection
Exactly.
before liftoff.
Right.
Well, this has been an incredibly insightful journey so far.
I agree.
We've gone from the basics of blockchain technology all the way to the intricacies of smart contracts
Yeah.
and the challenges of scalability and security.
It's a lot to cover.
But I feel like we've only just begun to explore the vast possibilities of Ethereum.
Oh, absolutely. We're just scratching the surface.
There's still so much more to uncover,
Right.
those decentralized autonomous organizations you mentioned earlier.
Yes, DAOs.
DAOs, they sound particularly intriguing.
They are. Yeah. DAOs
Mhm.
are one of the most revolutionary concepts to emerge from the Ethereum ecosystem.
Okay.
They have the potential to really change the way we think about organizations and governance.
All right. Well,
But I think we need to save that discussion for next time.
okay, yeah, we've covered a lot of ground already.
We have.
And DAOs, I think, deserve their own dedicated deep dive.
I agree.
So we'll take a quick break to let all this information sink in.
Sounds good.
And then when we come back, we'll dive into the world of DAOs
All right.
and explore how they might reshape society as we know it.
Looking forward to it.
All right, so welcome back to the deep dive.
Glad to be back.
So far, we've explored the foundational concepts of Bitcoin,
Right.
unpacked the inner workings of Ethereum.
Mm-hmm.
We even glimpsed the potential pitfalls this technology faces.
It's been quite a journey.
But now it's time to journey into a world that, to me, sounds straight out of science fiction.
Oh, yeah.
Decentralized autonomous organizations, or DAOs for short.
It's definitely a concept that captures the imagination.
Yeah.
Imagine an organization without traditional hierarchies.
Oh, yeah?
Where decisions are made collectively
Uh-huh.
and enforced automatically through code.
Okay.
It's like taking the power of a company
Right.
or a nonprofit and putting it directly in the hands of its members,
Okay.
all governed by a set of rules encoded in a smart contract.
So there's no CEO calling the shots.
Right.
No board of directors making backroom deals.
Exactly.
It's all out in the open, transparent, and controlled by the community itself.
That's the idea.
That sounds incredibly empowering,
It is.
but also a little scary.
It's both. And that's what makes DAOs so fascinating.
Right.
They offer a radical new way to organize and govern ourselves,
Uh-huh.
but they also present unique challenges.
Okay.
Think about it.
Yeah.
How do you ensure fairness in decision-making?
Right.
How do you prevent manipulation or hostile takeovers?
Yeah.
These are all questions the Ethereum white paper grapples with.
Yeah. I remember reading about some early DAOs that ran into trouble. Like the one that got hacked because of a vulnerability in its code.
Right, the DAO.
Yeah.
That was a big one.
Yeah, that must have been a huge setback for the whole concept.
It was definitely a wake-up call.
Okay.
It highlighted the importance of robust security measures
Right.
and careful coding when building DAOs.
Yeah.
But it also sparked a wave of innovation,
Okay.
with developers working on new solutions
Right.
to address those vulnerabilities.
So it's like they learned from their mistakes.
Exactly. They took those lessons to heart.
Okay.
One of the key takeaways from those early experiences is that code alone isn't enough.
Okay.
You also need clear governance mechanisms,
Right.
dispute resolution processes,
Gotcha.
ways to adapt and evolve as the DAO grows
Okay.
and faces new challenges.
So it's like building a constitution for a digital society.
That's a great analogy.
Figuring out how to balance individual freedom with collective decision-making.
It's a delicate balance.
That sounds like a pretty tall order.
It is, but that's what makes this space so exciting.
Yeah.
It's a grand experiment in decentralized governance, where we're trying to figure out how to create systems that are fair, transparent, and resilient.
And the Ethereum white paper,
Yeah.
even though it was written years ago,
Right.
provides a valuable framework for thinking about these issues.
Absolutely. It was ahead of its time.
It's amazing how this document, which is essentially a technical blueprint, also sparked this like philosophical debate
Yeah.
about the future of organizations.
It speaks to the visionary thinking behind Ethereum.
Okay.
It's not just about building technology. It's about building a better future.
Okay.
One where individuals have more control over their digital lives.
Right.
And can participate in shaping the systems that govern them.
So as we reach the end of our deep dive
Yeah.
into the Ethereum white paper,
It's been a pleasure.
what's the one key takeaway you want our listeners to walk away with?
That's a good question.
What's the big aha moment?
For me, it's the realization that we're on the cusp of a paradigm shift.
Okay.
We're moving from a world dominated by centralized institutions to one where individuals and communities can leverage decentralized technologies
Right.
to build and govern their own systems.
Okay.
It's a world full of possibilities,
Yeah,
but also challenges.
of course.
And the Ethereum white paper is a roadmap,
Yeah.
a guidebook
Yeah.
for navigating this uncharted territory.
Well said.
Thank you.
And to our listeners,
Yeah.
we encourage you to keep exploring,
Absolutely.
keep learning, keep asking questions.
That's the spirit.
The future of decentralized technology is being written right now,
It is.
and you have the power to be a part of it.
You heard it here first.
All right, that's it for this episode of The Deep Dive.
Until next time.
See ya!